Here we have sections 8.5, 8.6, and 8.7, factoring polynomials. So let's start learning how to factor by distributing. So what we're going to do in this section is we're going to take some polynomials and we're going to factor them by taking out the GCF. GCF is greatest common factor, and basically we find the factor that's the greatest between the terms, and we take it out and then we use it to factor the polynomial. As you'll see a little bit later on, when you multiply two polynomial factors together and you make it equivalent to 0, one of those polynomial factors equals 0. But this is all just words. Let's see what I actually mean in numbers, math. So here we have an example on how to factor using distribution. So first what we're going to do is find the GCF, and we have to look at these numbers and figure out which number or which term can divide into all of these terms. So first let's look at the variables. So each of these terms has at least one x. So because the middle one has an x squared, but the first one and the last one have x. So 8xy squared and 4xy both have 1x. So that's part of our GCF. The next thing is the y's, and they all have at least one y. Now the first two have y squared, so 8xy squared and 12x squared y squared, but 4xy does not have a y squared, so y is going to be part of our GCF. And also, if we look at the numbers, we can see that each one of these numbers divides by 4. And that's the greatest number they can divide by. So, they can all divide by, like 12 can divide by 12, obviously, but they can't all divide by 12. So, our GCF would be 4, which is the number, and then x, y. So, we have 4xy equals GCF, which again stands for greatest common factor. And now what we have to do is we have to just use the distributive property and just take 4xy out of this expression. So we do 4xy, and then in parentheses we put the terms, but we divide all of them by 4xy. So if we divided 8xy squared by 4xy, 8 divided by 4 is 2, and then it would be 2y, because the x is taken out and 1y is taken out. So then we have 2y plus, so if we take 4xy out of 12x squared, y squared, we would divide 12 by 4, which is 3, x squared by x, which is x, and then y squared by y, which is y. So we have 3xy, and then 4xy divided by 4xy is 1. So plus 1. And that is our fully distributed expression. So now let's move on to the next example. So for this next example, what we're going to do is we're going to factor by grouping. And basically, to try this, you have to have 4 or more terms, and they have to have common factors, which you can group, and you also have to have, there's 2 common factors that are identical, so you can do this method of factoring. So let's make the 2 groups. So we have 4xy plus 8x as one group, plus 7y plus 14. That's another group. Now, let's look at these groups for factors. So, for the first group, like we did in the first example, we just have to take the GCF out. So, we look at the numbers. The GCF is 4 because 4 is the largest number you can take out. And the GCF of the variables is x. So, the GCF is 4x. And then, if you take 4x out of 4xy, you get y. And then 8x divided by 4x is 2. So y plus 2. And then, on this side, the GCF is actually 7 because 14 doesn't have a variable, and the most you can divide by is 7. So plus 7, and then you can take this out, and then y, and then 14 over 7 is 2, plus 2. So you might think, oh, we're done, yay, woohoo. But there's actually a thing where these two are identical, y plus 2. That's what I said about how there have to be common identical factors. So, since these are equal, we can actually add these together because these are like terms. And if we add these together, you get 4x plus 7 times y plus 2. And that is actually how you factor this, the top expression. So this is actually really cool because you just have to look and figure out how you can use the distributive property in different ways to factor things like this. And now let's move on to the third example, which is actually solving equations with similar things to the solution down here. So here we have two factors, and this time we're actually going to solve these factors. So these are equivalent to 0, and we actually need one variable, which is x, because we're solving them. But so basically what you have to do in this situation is you have to think that at least one of these factors has to be equivalent to 0. So think of these as two variables. So if we did xy equals 0, so either x or y or both would have to be 0, because there's no other way that you can multiply two numbers together to get 0. So that's what we have to do with this situation. We have to assume that one of these is 0, but we don't know which, so we have to actually solve for both. And that's why, in this situation, you would get two solutions. So, how do you solve this? It's really simple. All you have to do is just try both solutions. So you get 4x plus 3 equals 0, 4x equals negative 3, x equals negative 3/4. Now that is one solution. But then we also have the other side, this factor right here. And what we have to do with this is we have to do the same thing. X minus 5 equals 0, and then just solve this. It's really simple. X equals 5. So our solution for this problem would actually be x equals negative 3/4 or 5. Could be any. There's no actual one solution. It could be any of these two solutions. These are the options for the solution because one of these factors has to be equal to 0, but we don't know which one. So this is section 8.5. So for recap, we learned how to distribute by finding the GCF and distributing the GCF out. And then we learned how to group and use those groups to make two factors, two binomial factors. And we also learned how to solve if you have two factors that are equivalent to 0, and how an equation can have two solutions. So, this is 8.6, the next unit. And for this one, there's not really a lot to do for notes. So let's just jump right in. And actually, this isn't really an example that we're going to solve. I'm just going to be showing you how this kind of section kind of works. So first, let's try something. So let's try foiling this expression. So we have first, outer, inner, last. So first, x squared, outer, 6x, inner, 5x, last, 30. So, and then we can simplify this, of course, to 11x plus 30. And so if you notice, these numbers right here, this 30 is the product of these two numbers, and this 11 is the sum of these two numbers. So, which is interesting because that means that we can actually get this back from this. And that's basically what this unit is kind of about. So, what we're going to do in this section is we're going to try to solve something like this. And so let's figure out how we can kind of do this. We already know what we're going to get, x plus 5 times x plus 6, but let's see how we can do that. So we already know that if we think of this as x plus a times x plus b, we know that a plus b equals 11 because this is 11, and a times b equals 30. So now we just have to think of two numbers. Now you can do this any way you want. You can make a table with factors, but since we already know what it is, we're just gonna skip ahead, and we know that this is gonna be 5 and 6. So now what you want to do is do x plus 5 times x plus 6, because you know the two numbers, because you know a and b, and equals 0, and then we can solve that like we did in 8.5. All we have to do is x plus 5 equals 0, so that x equals negative 5, and then x plus 6 equals 0, so x equals negative 6. And then these are our two solutions, so x equals negative 5 or negative 6. And that is our answer. So that's how this section works. Now let's go to an example of another problem like this one we have right here. The next part of this is when this number right here is negative. And the actual format for these polynomials are x squared plus bx plus c. And a and b are probably not the best variables to use for our two numbers that we have, that you saw in the last example. So let's change that to, say, I don't know, d and e. And it doesn't really matter, any variables, but that's just for simplicity. So let's try factoring this. Now you have to remember that d plus e equals negative 7, and de equals 12. Now, that doesn't really make a problem because two negative numbers can add up to negative 7, and if you multiply two negative numbers, you get a positive number. So now we just have to think, and again, I'm going to skip ahead. You can use any method you want just to figure out the factors. And now the factors, d is 3, and the variables are negative 3 and negative 4. So our two numbers are x minus 3 and x minus 4. And actually this was supposed to be equal to 0. So if we do equal to 0, and then we solve this, x minus 3 equals 0, x equals 3, x minus 4 equals 0, x equals 4. And those are our two solutions for this problem right here. And now let's move on to our last example. So the next step is learning what happens when this number right here, c, is negative. And you can see we have almost the same situation right here. But in this one, b is positive, and in this one, b is negative, and that changes some stuff. So, if you remember, this the two variables that we have, d plus e equals 6, and de equals -7. So that means that either d or e is negative. And if we don't want to change d or e to negative, we could write this as d minus e equals 6, and d times negative e equals -7. Now that works. So we have to think of two variables. And again, I'm going to skip this through. And the two variables are 7 and -1. So we see 7 minus 1 equals 6, and 7 times -1 equals -7. And that's our thing for this. And then we have x minus 1, x plus 7, and that's it for this one. Now, for the other one, it's a little bit different because this sign is negative. So, what we have to do is we have to basically just switch them around, because so the variables that we had over here are 7 and -1. Over here, the variables are going to be -7 and 1, because -7 plus 1 is -6, and -7 times 1 is -7. So, if we do, we can just skip the d and e part because we already know the variables. So we just get x minus 7 times x plus 1. It seems very similar, but you have to remember that if you change the signs, it changes a lot. So, and that's how do you do 8.6. So to recap, we learned how to factor polynomials in the form x squared plus bx plus c. And we learned how to do it when b and c are positive, when b is negative, and when c is negative. So, for the last section, what we have to do is so in the previous section, you know, we did x squared plus bx plus c. Now we have to do ax squared plus bx plus c. So in the last section, a was 1. Now a isn't going to be 1. So how we solve this is we have this number, which is a, and this number, which is c. We multiply them together, and that's our number that the two variables multiply together to make. So now that's a little bit hard to understand, so let's try it. So we have 16, that's the product, and then if you recall, we used the variables d and e. So d times e equals 16, and d plus e equals 10, because this is our number right here. So if we have de equals 16, d plus e equals 10, we have to think of the variables. Again, you can use a table or whatever method you like. So now what we have to do is the factors would be 8 and 2, and so 8 and 2, so then we have to do, for this one we actually have to use grouping. We can't just do x plus 8 times x plus 2. That doesn't work. No, that's wrong for this situation. What we have to do is we have to actually split this up into 8 and 2. 2x plus 2x, 2x squared plus 2x plus 8x plus 8. And then we have to group these like we did in 8.5. So then we have to do this plus. And then we have to find common factors, the GCF of each of these. So then the GCF of this one is 2x, because each of them have a 2x. 2x, and then times x plus 1, because this one has an extra x because it's x squared, and 2x over 2x is 1, so then it would be x plus 1, x plus 1. And then for this side, you take out 8, and then what you're left with is x plus 1 again. So we have these two, and like we did in 8.5, these are like terms, so we can combine them to get 2x plus 8 times x plus 1. And that's it for this example. So now let's move on to some more examples of how to do this. So another example is when we have this number b as negative, but this number c as positive. So all we have to do again is multiply the a by c, and then we'll get 8. So 8 d e equals 8, and d plus e equals negative 6. Now for this to work, both of the numbers have to be negative, because two negatives make a positive. So let's think of two numbers that make up 8 again, and add up to negative 6. So again, you can do this however you want, but the two numbers are negative 4 and negative 2. So now what we have to do is we have to group it. So 4x squared minus 4x minus 2x plus 2. And then put the parentheses in, and no, not like that. So you have to do if you want to put a parentheses for this one, you could do something like plus negative 2x plus 2, and then do that. Okay. And then take out the GCF for the first one. The GCF is 4x. 4x times x minus 1 plus, or actually minus, because there's a negative. You can take out minus 2, and that will make it the same as this. So we would have x minus 1 on that side as well. So you have to take out a minus. So then minus 2 times x minus 1, because 2 over negative 2 is negative 1. And then 4x minus 2 times x minus 1. And that is your solution. And now also you can just solve this like we did in the 8.5. Again, easy. 4x minus 2 equals 0. 4x equals 2. X equals 2/4 or 1/2. And x minus 1 equals 0. X equals 1. So x equals 1/2 or 1. And let's move on to our next example. So for the next part, what we have to do is figure out whether a polynomial is prime. And to do that, we have to basically figure out if it can be factored or not. So what we have to do is we have to try factoring and see if it works. If it doesn't, then it's prime. So let's start with this one. So we have negative 15, like we did before. And then we have DE equals negative 15, D plus E equals negative 2. And if you recall, in 8.6, what we did was we have to figure out one of these factors has to be negative, because the product is a negative number. And then we have to figure out if this number, if you take a number and subtract another number, those two numbers have to equal negative 15. And the answer has to be negative 2. So the numbers are negative 5 and 3. Again, you can figure it out any way you want. And then negative 5 and 3. So what you have to do is group this like this. Minus 5 x plus 3x minus 3. And then what we can do is we can group these like this, and now we can take out the GCF. For the first one, the GCF is 5x times x minus 1, because 5x squared over 5x is x, and negative 5x over 5x is negative 1. And then you can take out 3 from this next one, so 3, and then you can do x minus 1. So 5x plus 3 times x minus 1. And so that means this one is, it's not prime. So this one is fine. Now let's try the next one. For this one, what we have to do is, again, 16, DE equals 16, D plus E equals -3, and now we have run into a problem because there are no numbers that multiply together to give a product of 16 and that add together to give a sum of 3 or -3. So that's a problem, and that means since there are no factors that this polynomial is prime. And just to recap, what we learned in 8.7 was how to factor the form ax squared plus bx plus c, and we learned how to factor it in different ways. We learned how to figure out how if a polynomial is prime, and that's it for this video.